All right, let's just dive right into this explainer and uncover the mechanical muscle behind, well, nearly every modern product used today. You know, when you tap your smartphone, get a package delivered the very next day, or even drive a new car, you're actually interacting with the output of this massive, mostly invisible workforce. Today, we're exploring this super fascinating world of industrial robotics. We're going to break down the sources, the data, and the crazy engineering that makes the entire global supply chain possible. Now get a load of this number, 2 million. What's absolutely wild here is that this represents the 2 million robotic-assisted surgeries performed globally every single year. Yeah, 2 million. It totally shatters that illusion that industrial robots are just, clumsy sci-fi tropes or dumb machines bolting doors onto cars. As our sources from ANSYS point out, these systems have such unbelievable dexterity and precision that surgeons literally use them as extensions of their own hands to save lives. It's a real game changer. So, here's our game plan for today. We've got 5 parts. 1, meet the workforce. 2, the robot roster. 3, Cartesian action. 4, weighing the pros and cons. And 5, tomorrow's automation. All right, Section 1, meet the workforce, the backbone of modern industry. To really understand this workforce, we have to completely forget about the walking, talking androids you see in the movies. According to our engineering sources, industrial robotics is hyper-focused on specific, repetitive, or hazardous tasks. These aren't built to look like us. They're highly specialized machines engineered for superhuman logistics and quality control. They are built to totally outperform us in environments where human hands would either slow down, introduce errors, or, frankly, be put in real danger. And the scale of these deployments, it is honestly staggering. To wrap your head around it, Amazon alone has deployed over 1 million robots in its warehouses to handle automated picking, placing, and sorting operations. Meanwhile, an estimated 65% of all automotive businesses rely on these systems for high-speed assembly and welding. So whether it's putting together your phone or sorting your online orders, robots are absolutely the foundational workforce of the global economy. Moving right along to Section 2, the robot roster. Let's meet the cast of characters. You know, just like human workers, different robots have totally different specialties. It's this perfect taxonomy of motion, drawn right from iLearn Engineering. Take a Delta robot with those unique parallel arms. It acts like a total speed demon, plucking and sorting lightweight items for food packaging. Then you have a 6-axis robot, which is basically the ultimate flexible acrobat, mimicking a human arm for complex auto welding. The Skara robot dominates horizontal movements for electronics, and the cylindrical robot gives you robust rotational reach for heavy metal fabrication. It really is all about matching the precise mechanical geometry to the exact task at hand. So where are all these machines actually hanging out? Well, let's look at the electronics sector. They use about 1 million of these specialized robots, and the deployment is heavily concentrated. 42% of this entire market is in the Asia-Pacific region, which totally makes sense given the intense demand for intricate, high-speed component assembly. Think smartphones, circuit boards, all that good stuff. Europe follows up at 28%, with North America sitting at 23%. Which brings us to Section 3, Cartesian action, the true workhorse of plastics. To see how these systems operate in the real world, we've got to look at the ultimate workhorse, the Cartesian robot. Unlike the sweeping, super complex arm of a 6-axis robot, a Cartesian relies entirely on straight, rigid lines. It just moves along the X, Y, and Z axes. By sticking to these orthogonal linear paths, it creates this highly precise, completely predictable, cube-shaped workspace. And that rigid predictability, that makes it the absolute ultimate tool for extracting plastic parts out of a mold exactly the same way every single time. The raw specs on these machines, highlighted by sources like Festo and Yushin America, are just staggering. We are talking about pinpoint accuracy down to plus or minus 0.0025 millimeters. You literally can't even see that. They can extract parts at blistering speeds, sometimes in just 0.27 seconds. That is incredibly fast. Plus, because they mount overhead, they save critical factory floor space while effortlessly handling heavy plastic molds with microscopic accuracy over and over without ever degrading. To really visualize how this works, let's break down a typical injection molding cycle into 4 rapid-fire steps. First, the robot traverses over the open mold. Second, the vertical axis drops in to grip the newly formed part. Third, it retracts straight up out of that incredibly tight space. And fourth, it traverses horizontally to drop the part on a conveyor. All of this happens in mere fractions of a second, perfectly synced up with the manufacturing machines. It's literally like a highly choreographed dance.
Okay, let's step back a bit for Section 4, weighing pros and cons, the true cost of automation. Look, it's not all just plug-and-play magic. There are massive, real-world trade-offs to deploying this workforce. On the pros side, the benefits are basically undeniable, right? Massive 24/7 productivity gains, way less waste, and keeping humans completely out of toxic or hazardous environments. But on the con side, companies face huge upfront capital costs and a ton of systemic complexity. And as our sources note, there are very valid societal concerns regarding human job security. It is a profound shift in the labor market, and industries are actively having to navigate this right now.
And finally, let's dive into Section 5, Tomorrow's Automation. We're looking at AI, simulation, and soft robotics. As physical hardware fully collides with the digital software revolution, the whole future of this industry is becoming highly collaborative. Enter the cobots, collaborative robots. These guys are breaking out of their traditional safety cages to work directly, literally shoulder to shoulder, with humans. Using advanced spatial awareness sensors, they dynamically prevent collisions. At places like BMW's assembly lines, they empower human workers by taking over the physically exhausting tasks, creating this really cool hybrid workforce of human ingenuity and mechanical endurance. And the financial stakes backing these innovations? Immense. The global demand for faster logistics and precision healthcare is driving massive, massive market growth. Get this, warehouse automation is projected to hit $41 billion by 2027, and healthcare robotics could reach a staggering $54 billion by 2034. There is so much capital fueling this next generation of robotic intelligence. To keep up with that crazy demand, engineers are completely rewriting the playbook on how these machines are built. We're moving way past the expensive physical prototyping and the weeks of trial and error that define the past. The future is all about digital twin simulations, instant online configurations like Festo's handling guide online, and even transitioning from rigid metals to flexible elastomers. This is known as soft robotics, and it actually mimics animal biology. Honestly, software is the secret weapon here. By testing multiple physics variables in a digital space, companies can perfectly predict a robot's operational limits without ever breaking a single physical part. Using tools like Ansys Twin Builder for system models or Maxwell solvers to perfect the electromagnetics of a motor, engineers can simulate extreme crash environments entirely in the cloud. It saves literally millions in development costs and drastically speeds up deployment. But here's where it gets really sci-fi. Ultimately, this software layer is providing robots with true cognition. Through deep sensor integration, machine learning, and zero-latency 5G connectivity, advanced AI is granting these machines human-like perception. They can now autonomously navigate unexpected warehouse obstacles, recognize hand gestures, and, get this, even predict their own maintenance failures before a breakdown ever occurs. Which brings us to our final thought for today. As this invisible workforce becomes deeply integrated into our daily routines, gaining AI cognition and working uncaged right beside us, how will our relationship with these intelligent machines evolve? Are they just advanced tools, or are we entering an era of genuine collaboration? It's a fascinating question and one we're all going to have to answer very soon. Thanks for joining me on this explainer, and keep learning.